Dear students, welcome to today's class. So last two classes onwards, we are discussing about set theory. So now in today's class, I am going to explain subsets, operations on sets, symmetric difference of two sets, complement of a set, algebra of sets. Okay now. So these topics are very fundamental topics in set theory. They are very useful for your board examinations and CBSE examinations and your JEE mains, NDA, any examinations. Okay na? So let us start our class. Now let us see what is subset of a set. Okay na? So let us take one example. Let A be a set 1, 2, 3. Now let us write all the subsets of this set S1, that is equal to set containing element 1. That is 1 is the subset of 1, 2, 3, right. Second one is 2, set 2. S3 is equal to set 3. S4 is equal to 1, 2. S5 is equal to 1, 3. S6 is equal to 2, 3. S7 is equal to null set. S7 is equal to null set. And S8 is equal to 1, 2, 3. So here if you observe, we got 8 subsets. 8 subsets. All are subsets of the set A. So for these subsets, we have a one name, that is up to here. So these subsets are called proper subsets. They are called proper subsets. Okay now. The set itself is there? No. This is called improper subset. Improper subset. The set of all these sets, they are called proper subsets of the set A. The set itself is called no. That is called improper subset of the given set. Now my question is, given a set, how many subsets we can write? Since here it is a small set 1, 2, 3, you are able to list out all the subsets. If I am given 1, 2, 3, 4, 5, something like this given, so can you say the number of subsets? How many subsets are there? Can you say that? Okay, improper subset is 1, that everybody knows that itself. And null set is a subset of every set, that is also known. But what about the remaining subsets? How many subsets we are going to see? So for that there is a formula. Now I am going to derive the formula. Okay na? So let us see the derivation. Now I am going to derive this formula, that is if n of A is equal to m, then the number of subsets of this set A is equal to 2 power m. That means if a set contains m elements, then the number of subsets of A is equal to 2 to the power of m. Now I am going to derive this formula. So to derive this formula, so we have one result from binomial theorem. So what are the results? See here, x plus y whole power n is equal to nc0 x power 1 nc1 into x power n minus 1 into y plus nc2 into x power n minus 2 into y square. So on last term ncn into y power n. Okay now, put wherever x is equal to y is equal to 1. X is equal to 1, y is equal to 1. So what happens? nc0 1 to the power of 1 plus nc1 1 to the power of n minus 1 into 1, 1, 1, 1. So ultimately what you will get? nc0 plus nc1 plus nc2 so on. ncn 1 to the power of n is equal to 1 is equal to 1 plus 1. 1 plus 1. How much? 2 to the power of n. So this is the formula you have, nc0 plus nc1 plus nc2 plus ncn so on, and 2 to the so on ncn is equal to how much? 2 to the power of n you have. Now coming to our problem here. So here our problem is A contains m elements. 1, 2, 3 so on m elements. How many elements it has? M elements, m number of elements are there. Now coming to the permutations and combinations. number of the subsets which contain no elements. Number of combinations of the sets which contain no element. That means only one, that is equal to MC0. Okay, right. Next, what are going to do? The number of subsets of the sets which contain only one element. So that means what? How many we can take? So according to the formula, total number of elements are m. From that, you have to select one element, that is equal to MC1. Next one, number of subsets which contain two elements, that is equal to MC2. Number of subsets which contains three elements, MC3, plus so on. Last and final, improper subset. That means the set which contains all the elements, that is equal to MCM. See here, according to the formula, what is that? MC0 plus MC1 plus MC2 plus MC3, so on. MCM is equal to 2 to the power of m. Understand this formula? So this means what? The set containing only one element. That means the set containing no element. This is the sets containing one elements. These are the subsets which contain two elements. These are the subsets which contain three elements, so on. This is a subset itself. MCM means all elements you are taking, only combinations, no permutations. Okay, here no need of any arrangements here, just a selection, that's all. Understand this derivation? So this is the derivation for the number of subsets of the set A is equal to 2 power m. Okay, so from this we are going to derive two more formulas. Okay, so let us see that. So as I already told you, in the subsets, one is improper subset, remaining all proper subset. Therefore, the next formula is the number of proper subsets. Number of proper subsets is equal to 2 power m minus 1. Number of proper subsets is equal to 2 power minus 1. What is minus 1? Itself is there, no, that is improper. That wise we have to subtract from that. So from this, in the proper subsets, one is empty set. Empty set is also a proper subset. Now, if you also subtract from that, that is called the number of non-empty proper subsets. Non-empty proper subsets is equal to 2 power m minus 2. So therefore, the number of subsets is equal to 2 power m, number of proper subsets is equal to 2 power m minus 1 means why we have to subtract? 1 is subset, which is a improper subset itself. That means the number of non-empty proper subset means in the proper subset, one is an empty set, no. If you have to subtract from that, remaining all are called non-empty proper subset. So these are the first formula derivation. You have to learn the derivation for this 2 power m. Afterwards, these two are nothing. From the definition itself, they will come. Okay, na? So I hope that you understand this concept. So let us go for next problem, next concept. What is meant by operations on sets? So given two real numbers, we know there are 4 fundamental operations in real numbers. For example, if any two numbers are given A and B, we know the addition of numbers, you know the difference of numbers, you know the product of the numbers, you know the division of the numbers, of course, when B not equal to 0. So this is called addition of numbers. This is a difference of two numbers, otherwise subtraction of two numbers. This is called product of the two numbers or multiplication of two numbers. This is called division of two numbers. That means this is addition, subtraction, multiplication, division. These 4 are called fundamental operations in the set of real numbers. Like that, given two sets, whether maybe empty or non-empty. Given two sets A and B, what can we do with them? Whether you are union, the intersection, what we can do. So here also we have 4 fundamental operations on set. The first one is union of two sets. The union of two sets, we will denote it as A union B. Okay, now one by one detail I will explain. Okay, second one is intersection of two sets. This is denoted by A intersection B. And the third one is difference of two sets. Difference of two sets. This is A minus B or B minus A. I will explain what is A minus B or B minus A. Fourth one is product of two sets. Sometimes it is also product of the two sets is also known as Cartesian product of two sets. Cartesian product of two sets. This is denoted by A cross B or B cross C. Understand? Both are different. That's why I write down A minus B, B minus A, both are different. So these are the four fundamental operations which were defined on the sets A and B. So for your kind information, there is no division of sets. There is no division of sets. That is not defined. Only union of two sets, just like addition, intersection of two sets, a difference of two sets, product of two sets. This is also known as Cartesian product of two sets on the horn in the name of René Descartes. René Descartes, great mathematician, Cartesian product of two sets, either A cross B or B cross A. Okay now. So let us learn one by one what is a union of two sets. Okay, intersection of two sets. Let us learn one by one. Okay. Let us see what is union of two sets. Okay now. Let us take A and B be any two sets. A and B be any two sets. I am not saying here non-empty. Maybe empty or both are empty, or one may be empty, another may be finite. Whatever may be that. Any two sets. Then the union of two sets is denoted by A union B. What is the symbol? Union. A union B. And it is defined as the set of all the elements X such that either X belongs to A or X belongs to B. Either X belongs to A or X belongs to C. Sir, what is this? I will give one example. A is equal to 1, 2, 3 and B is equal to 3, 4. That means now A union B is given by the, what is that given? Either X belongs to A or X belongs to B. That means you have to take all the elements which belongs to either A or B. So that means either A means tell what are the elements all which belongs to A, 1, 2, 3. Tell me the elements which belongs to B, 3, 4. So generally in a set we cannot write down the repeated elements. That's why 1, 2, 3, 4. So this is your A union B. Understand the definition? Right. So what about B union A? B union A. So B union A also, if you observe the elements which belongs to 3, 1, B or which elements which belongs to A. So this is nothing but 1, 2, 3, 4. That means A union B, B union A. Understand? So this is the very basic fundamental definition of A union B. Understand? Now we are going to see the Venn diagram. So this is a very, very important. So John Venn is a great mathematician. He represented all the set operations in Venn diagrams. Okay. So if I explain you in the Venn diagrams, you can easily understand. Okay. So let us see the Venn diagram of A union B. Dear students, welcome to the Venn diagram of union of sets. So let us take the universal set. Generally we represented it in the rectangular box, universal set. In this set, you will take two overlapping set. You may ask one thing, sir, why we should take overlapping set? Unless otherwise said, we have to be considered that those two sets, at least there will be a one common element. Sir, if it is not a overlapping sets, then what about, sir, other way? You can take like this also. They are called disjoint sets, A and B or A intersection B. Now, what about union means what? A union B, how you are taking? A union B means the elements which belongs to either A, that means these elements you are taking, these elements, the number elements which belongs to either B, either A or B. So this is your A union B, complete elements you are taking. So the elements which belongs to A union B or B union A. So this is called the Venn diagram of A union B. So this is called Venn diagram of A union B. Sir, if it is a not overlapping set, they are called disjoint sets. Disjoint set. Then what about A union B? So this is your A and it is your B. A, B. That's all. That's all. Understand that? So here we are going to see one important property is there in a union of two sets. Okay. Let us see that important property. So the important property is X belongs to A union B means what? X belongs, that means if an element is belongs to A union B means either it should belongs to A or it should belongs to B. Either it should belongs to A or it should belongs to B. That means, so if it is a union B, this is a union B. So if you take this, this is a union B. This is A union B. That means if you take an element, either it should be in A or it should be B. Of course, it should be in A intersection B also. Here the question is, if it does not belongs to A union B, what happens? If it does not belongs to A union B means what? It should be out of that box, out of these two sets, not out of that box, out of the two sets, union set. That means definitely it should not belongs to A and it should not belongs to B. That means your element is here. Your element is here. Definitely it should not belongs to A and it should not belongs to B. Understand this concept? Understand? So these two concepts are important for to do the problems in statements, okay, which is a very important topic in your JEE mains examination. So if X belongs to A union B means X belongs to A or X belongs to B. If X does not belongs to A union means that element is out of that A union B, that is outside A union B. That means must be does not belongs to A and it does not belongs to B. Okay, na? Right. So let us see the intersection of two sets. Okay. Let us take the intersection of two sets. What is meant by intersection of two sets? Let us take A and B, any two sets, Then the intersection of A and B is denoted by the symbol. This is called intersection and it is defined as the set of all the elements which belongs to A and B. The set of all the elements which belongs to A and B. Understand this? This is called intersection of two sets. Sir, let us give me one example. Let us take A is equal to 1, 2, 3 and B is equal to 2, 3, 4. So what about A intersection B? Now tell me what are the common elements present in both the sets? 2, 3. And the same as B intersection A is also 2, 3. A intersection B, B intersection A, both are same, 2, 3. Very easy concept, okay. Now coming to the Venn diagram. So this is a universal set. You are taking two non-empty sets A and B. Therefore, what is the intersection means what? What is the common part here? So this is A intersection B. These two are called overlapping sets. Okay, now, sir, if they are not overlapping sets, sir, what about if they are not overlapping? They are called disjoint sets. Then what about that A intersection B? Is there any common element? No common. That is null set. So when there is no common element between any two sets, between two sets, they are called disjoint sets. So these are called overlapping sets. Unless otherwise stated, if at all, if anything, in any problem, if any two sets are given, we have to think always overlapping sets. Unless otherwise stated. If they stated that they are A and B are disjoint sets, then you have to consider that. Okay, na? So this is regarding the definition. All properties are also there. I don't put in property, identity properties. All properties at one place I will explain. So this is a very basic fundamental concept. Okay now. So here we have one important property in this intersection of two sets. Let us see that. So here one basic very important note point in the intersection of two sets is, if x belongs to A intersection B, that implies x belongs to A and x belongs to B, compulsory. If it is, suppose f does not belongs to A intersection B, if it is does not belongs to A intersection B, then what happens? You see here. So see the Venn diagram, A, B. So this is A intersection B. When an element does not belongs to A intersection B, means either it should be in X or it should be in B. Understand? That means X does not belongs to A intersection B, means that means X does not belongs to A. It should not belongs to A. That means this you call it as Y. That means the element Y. The element Y. Y does not belongs to A. Y does not belongs to A. Or X does not belongs to B. That means see here, X element here, X does not belongs to B. That means if you observe this part, the elements which present here, they does not belongs to A. The elements which present here, they does not belongs to B. So altogether either here or here, the elements they does not belongs to A intersection B. So this is a very important concept. When you are saying does not belongs to, here does not belongs to come, does not belongs to come, here and or come. In the previous example, or and will come. Understand this? So very important concept this is. Okay. Now let us see the difference of two sets. Let us define what is difference of two sets. Okay now. So let us take A and B are any two sets. A and B are any two non-empty sets. Then the difference of A minus B or B minus C. The difference of A minus B or B minus A. Now the difference of A minus B is defined as a set of all the elements X such that X belongs to A and X does not belongs to B. That means it should belongs to only A. So we should not take the elements which belongs to B. B means B minus A means the set of all the elements belongs to B and they does not belongs to A. Okay now. So this is a very fundamental definition of A minus B. Okay, I will explain with you in some example. Let us take A is equal to 1, 2, 3, 4. B is equal to 3, 4, 5, 6, 7. Okay. Now what about A minus B? A minus B is given. What is A? 1, 2, 3, 4 minus what is B? 3, 4, 5, 6, 7. Okay. Now you have to take the elements which belongs to A and you should not belongs to B. That means we have to we should not consider the elements which belongs to both A and B. See here, these 3 belongs to B also. That's why you have to remove this. This 4 belongs to B also. That means this 4 also you have to remove. Then we have to take the elements which belongs to A only. So this is equal to 1, 2. Understand this? Now what about B minus A? B minus A is equal to, what is B? 3, 4, 5, 6, 7 minus, what are the set of elements of A? 1, 2, 3, 4. Okay. Now what is the definition? You should take the elements which belongs to B, but they should not belongs to A. See here, 3 belongs to both the sets. 4 belongs to also A. So this is given by 5, 6, 7. So in general, we can say that A minus B is not equal to B minus A when A and B are both are not equal to. Okay. Now let us see the Venn diagram of A minus B and B minus A. A minus B B minus A. So, see the Venn diagram here. So, this is a union, universal set. A and B are overlapping sets. A, B, are two sets, overlapping sets, unless otherwise stated, right? What about A minus B? So, you are taking the elements which belongs to A only. They should not belong to B. That means this is the region which is A minus B. A minus B is the region, shaded region. Okay, now what about B minus A? The elements which belongs to B only, they should not belong to A. This is B only. So, this is a B minus A is equal to, so this is the B minus A. So, this is a minus B and B minus A, they are very, very clear that A minus B is not equal to B minus A. Okay. So, here also we have a very important note point here. So, let me explain that. The important note point is, if X belongs to A minus B, then you are saying X belongs to A and X does not belong to B. Okay, now, for suppose if X does not belong to A minus B, what can you say that? For example, see the Venn diagram here. This is A, this is B. This is A minus B. You are saying A minus B. That means if an element does not belongs to A minus B. So, here it is not A minus B. Here it is not there. So, either it should be in A intersection B or it should be in B. That means definitely it should not belongs to X, does not belongs to A, or maybe belongs to B, or may it belongs to B. You may ask doubt, sir, if element is here, then it is belongs to A, no? No, it belongs to B. I am saying that, or X belongs to B. So, here if you take the element X here, surely that may, you may say that it does not belongs to, for example, one element is also here X. The element X does not belongs to A, but it belongs to B. If you say the element is here, it is belongs to B. That's why our X belongs to B. Understand this concept? Right. So, here also for B minus A also the same thing applies. For example, if X belongs to B minus A, that implies X belongs to B and X does not belongs to A. If suppose if the element does not belongs to B minus A, then it is X surely it should not belongs to B, or it belongs to A, or it belongs to A. Understand? So, very, very important topics these things. Okay, now. So, we have explained about union of sets and difference of two sets, and next we have said intersection of two sets. Now, what is the product of two sets? That topic I will explain in the next chapter, that is relations. Okay, there I will explain the chapter, that topic. Okay, now. So, let us come to next topic. I am explaining some important results here. Important results I am going to explain. What is important result means? When A is subset of B, when A is subset of B, what about A union B and A intersection B, A minus B, B minus A? Let us see that. When A is subset of B means, what is the Venn diagram for A subset of B? So, this is A and it is B. This is the Venn diagram of A subset of B. What about A union B? A union B means whole thing will come, that is nothing but B. What about A intersection B? A intersection B means what is the common of A and B? What is the common of A and B? That is equal to A. What is A minus B? When A subset of B, what about A minus B? See here, give one example. For example, A is equal to 1, 2. B is equal to 1, 2, 3, 4. Clearly A subset of B. What about A minus B? The set of all the elements which belongs to A only. If you observe here, 1 belongs to B, 2 is also belongs to B. Are you getting any exclusive elements which belongs to only A? No. That's why null set. B minus B is null set. What about B minus A? B minus A you won't get null set, but you will get a finite set. you will get some finite set, some elements there 3, 4 is your B minus A, some finite set. So, when A is subset of B, what about A union B, A intersection B, A minus B, B minus A, that also you should know, okay, right. So, using Venn diagram, some more results we have. Let us see that result. So, dear students, let us see the Venn diagram of A union B, A intersection B. So, this is A and it is B. It is A and A union B. So, if you observe, so this part is A minus B, this part is A intersection B, this part is B minus A. Clearly, the first thing what you have to observe is A minus B, A intersection B, B minus A. All three are disjoint sets. Already I told disjoint sets. Disjoint sets means what? A intersection B is equal to null set. Disjoint sets. That means first thing what you have to observe, A minus B, A intersection B, B minus A are disjoint sets. First thing. Second thing what you have to observe is A minus B is subset of A. A minus B is subset of A. A minus B is subset or equal to A. Sir, what is, why you are writing subset or equal to? Depends upon the elements of A and B. Sometimes A minus B is equal to A. That means if A and B are disjoint sets, A minus B is equal to A. Right. Again, second one, third one, A intersection B is subset of A. A intersection B is subset of B. A intersection B is subset of A. A intersection B is subset or equal to, sometimes may be equal to. Third one is B minus A is subset or equal to B. B minus A is subset or equal to B. So, this is the thing that you have to derive, learn from these Venn diagrams. First of all, A minus B, A intersection B, B minus A, they are disjoint sets. Second one is A minus B. If you observe this, so this is your A, this is your A. Your A minus part is this. That means A minus B is a part of A. A intersection B is a part of A, or A intersection B is a part of B. B minus A is a part of B. That means B minus A is subset or equal to B. Understand? So, this is also a very, very important concept that we should learn from the Venn diagrams. Okay, now I hope that you understand this concept. Dear students, let us see one more concept in set theory, that is what? Symmetric difference. Symmetric difference of two sets. Symmetric difference of two sets. Let us take A and B any two sets. Any two sets. Let us take A and B is any two sets. Then their symmetric difference is denoted as A delta of B, and it is defined as A minus B union B minus A, or sometimes it is also defined as A union B minus A intersection B. So, this is the symmetric difference of A and B. So, coming to Venn diagrams, if you see the Venn diagram, so this is equal to A and it is B, it is a universal set. The symmetric difference of A delta B means it is given what? A minus B. A minus B means what? This is A minus B. Okay, right. Next one what? B minus A. So, this is B minus A. This is B minus. So, the elements which belongs to either A minus B or B minus A. That means the elements which we does not require A intersection B. The elements which belongs to both A and B does not require. So, either it should belongs to either A or it should belongs to B. Either A minus B or B minus A. Otherwise, total A union B minus A intersection B. So, this is the symmetric difference of two sets. Here we have a very, very important properties here. The first one is, what is A delta A? A delta A. See here, A delta A means what? A minus A union A minus A. A minus A means what? Null set. B minus A, here also A minus A, null set. That means null set union null set, null set. Understand? Second property is A delta phi is equal to A. That means A minus phi is A union, phi minus A is phi only. That's all. That is A delta phi. Third one is A delta B is same as B delta A. The difference will come, that's all. A delta B, B delta A. Fourth one is if A delta B is equal to A delta C. If A delta B is equal to A delta C, then we can conclude that B is equal to C. We can conclude that B is equal to C. Next one is A delta B delta C is same as A delta B delta C. That is associative property satisfies. Next property is A union B delta C is same as A union B delta A union C. Next, same as A intersection B delta C is same as A intersection B delta A intersection C. So, that is distributive properties also satisfies. Understand this? So, these are the very, very important properties of symmetric difference of two sets. Okay, now, after this concept, let us see the algebra of set. That means what? What are the properties, union, intersection properties, and the commutative laws, associative laws, distributive laws, identity laws, all together I am going to explain. Okay, now? Dear students, see this algebra of sets. We have some laws. First one, idempotent laws, that is A union A is equal to A. That means take any two same sets A, their union also automatically will come A. A intersection A is equal to A. Next one, commutative laws. For any two sets, A union B is same as B union A intersection B is same as B intersection A. Identity laws, A union phi means null set, that is A union mu is equal to mu, A intersection phi is equal to phi, A intersection mu is equal to A. That's why here if you see here A union phi is equal to A. Here you are saying A intersection mu is equal to A. See these two things, A union phi and A intersection B. That's why null set is called the identity element in the union of sets. Mu universal set is called the identity set, identity element in the intersection of sets. Okay, na? Right. Next one, associative laws. That means A union B union is same as A union B union C. That means if you take three sets, first find out B union C, then A. The same result you will get when you find A union B with C. A intersection B intersection C is same as A intersection B intersection C. Next one, distributive laws. So, here union associative laws, you will have a same operation, union, intersection, intersection. But coming to distributive laws, see here union, intersection will come. A union B, intersection A union C. That means A union B and A union C, the middle intersection will come. A intersection B, A intersection C, middle union will come. Same as A minus of B union C is equal to A minus B intersection A minus C. If it is union is there, intersection will come. If it is intersection is there, union will come. Next one, complement laws. So, mu complement is equal to phi complement is equal to mu, and A union A complement is equal to universal set, A intersection A complement is equal to phi, A complement whole complement is equal to A. Understand this? So, very, very important formulas this is. Next one, De Morgan's laws also there. De Morgan's laws. De Morgan's laws. There are two De Morgan's laws are there. So, they are this. So, what is the first one is A union B whole complement is equal to A complement intersection B complement. Whereas A intersection B whole complement is A complement union B complement. A intersection B whole complement is equal to A complement union B complement. Okay, na? So, these are the some few laws regarding set theory. Okay na? So dear students, I hope that you enjoyed today's class. In the next class, I will come before you with some problems which were very important, which were given in the previous JEE mains examinations and competitive examinations. Until then, all the best.